Kia ora Year 12. This is question 10 from the November 2015 paper. It's a really nice example of some differentiation and then some integration, and this one is for Josh. So we've got a diagram showing us the curve for this function here. So y is equal to x squared plus 1 over x cubed, and it's got a maximum point on it at point M. And then we've got a shaded region R, and that's enclosed by the curve, the x-axis, and the lines x equals 1 and x equals p. So we're going to use that in part 2. But in part 1, all we have to do is to find the exact value of the x coordinate of M. So M is a maximum point, so we're going to differentiate and set that derivative equal to 0. And we know that we've got an x value that has to be positive. Okay, so if y equals x squared over 1 plus x cubed, the best way to differentiate that is to use the quotient rule. So dy by dx is equal to 1 plus x cubed squared. So it's 1 plus x cubed times 2x minus the other way around. So x squared times 3x squared, right? So what am I doing here? Well, I'm first of all copying this up the top and differentiating the numerator, and then I'm doing it the other way around, so minus this times the derivative of the denominator, and that has to equal 0 for a maximum. Okay, so that's a necessary condition to have a maximum point. It's not a sufficient condition, but it's a good enough condition for us to work with now. Okay, so to clean that up, we don't have to worry about the denominator because that's always going to be positive or equal to 0. So we know we can't have x cubed, x can't be equal to negative 1, but that's fine because x is positive anyway. So we can ignore the denominator. Cleaning up the top line gives us this 2x plus 2x to the power of 4 minus 3x to the power of 4 is equal to 0. So 2x minus x to the power of 4 equals 0. Factorising that gives me x times 2 minus x cubed is equal to 0. So x is equal to 0, or 2 is equal to x cubed. Now let's just go back and have a look. Right, so we know that we've got a minimum at the origin. You can see it here. And you can see that we need x is positive. So x is greater than 0, therefore x is equal to the cube root of 2. And we were asked for the exact value, and we were just asked for the x coordinate. So that's all we had to do. I'm just going to hop over to the mark schedule and check that I haven't missed anything out. Okay, so here it is here. Yep, no, that's fine. Okay, so they didn't need us to do a second derivative test or anything like that. So that's the first part done. Now let's look at the second part where we have to do some integration. So calculate the value of p for which the area of R is equal to 1. So we're going to evaluate an integral, and we have to solve for the limit of integration. So we want this. The integral between p and 1 of this function has to equal 1. So if you look at this, you'll see that we've got the pattern that we really like. We've got the denominator here, and the derivative of the denominator is 3x squared. While sitting up the top, we've got x squared. So that makes it a very easy reverse chain rule. I wouldn't bother doing any substitution on this, and if you do need to use substitution on this, I think that you probably need to be going back and doing some more work in the Delta book. Most of you should be able to see that this is going to be one of these patterns. So when I differentiate 1 plus 3x squared, 1 plus x cubed, I get 3x squared. I just want x squared, so we need to multiply through by 1/3. Now the other thing to notice here is that I know that 1 plus x cubed will be positive because my limits are p and 1. So I can drop those absolute value signs. Okay. Right, so we get to here, and we just need to work this through, and we're asked for an answer to 3 significant figures, but we'll use exact values as far as we can. So here, we start by, let's take the constant out the front. I'm going to do this in lots of steps. So substituting in, I get the log of 1 plus p cubed minus the log of 2 is equal to 3. Right, so I've multiplied both sides by this. I'm going to keep working this through as exact values. So putting that log back in together into one log, I get 1 plus p cubed over 2 is equal to 3. To undo the natural log function, I exponentiate both sides, or I e to both sides. That leaves me with 1 plus p cubed over 2 is equal to e to the power of 3. 1 plus p cubed is equal to 2e to the power of 3, and so on. P cubed is equal to 2e cubed minus 1. So p is equal to the cube root of this. So that's the exact value. And when we put that into our calculator, we get out p is roughly equal to 3.40, and that's to 3 significant figures. So there you go, 2 really nice examples of maximum points and solving a problem where we have to find the limit of integration. Let me know if you've got any questions, and keep on emailing me with problems that you want me to video. Thanks.